There's a very straightforward way of cutting down the latency, like the tail latency in your requests. So if you have a request, let's say that you have a request that you send into a server and it takes 5 milliseconds 99% of the time, but then there's 1% of the time that it takes 1 minute, which is not good. So what you could do is make that call multiple times, and you're going to do it with cancellation. So you're going to do context with cancel of your original context. And then what you're going to do is you're going to use the same context for all of those calls and have defer cancel at the top of your function. And then as soon as any of those values returns and you return from that function, the rest will be canceled. And that's going to take down your 99th percentile from like 1 minute down to 5 milliseconds.
Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. What up, friends? You might not be aware, but we've been partnered with Linode since 2016. That's a long time ago. Way back when we first launched our open source platform that you now see at changelog.com, Linode was there to help us, and we are so grateful. Fast forward several years now, and Linode is still in our corner, behind the scenes helping us to ensure we're running on the very best cloud infrastructure out there. We trust Linode. They keep it fast, and they keep it simple. Check them out at linode.com/changelog.
Let's do it. It's go time.
What's up? Welcome to Go Time, your source for diverse discussions from around the Go community. Today, Matt Ryer and Jana Doken are joined by Francesc Campoy and Isobel Redelmeier to discuss Go's context package. All right, here we go.
Hello, and welcome to Go Time. I'm Matt Ryer. Today we're talking about the context package. We're going to find out what it is, how we should use it, how we shouldn't use it. And on this journey today, we're joined by Jana Doken. Hello, Jana.
Hey, how are you?
Good, thanks. Welcome back. Have you had a good week so far?
Yeah, it's kind of slow here. I'm not sure what's going on there. Like, it's just, we're in the same cycle every day. So I'm not sure if it's good or bad.
Yeah, I know what you mean. Yeah, everything sort of starts to blend together, doesn't it?
Yeah.
Don't worry, though. This episode will, one way or another, change that for you. We're joined by one of our favorite gophers. It's Francesc Campoy. Hello, Francesc. Welcome back.
Hey, how's it going?
Good. Well, are you having a nice week this far?
Yeah, I mean, what Jana was saying, it's just all days the same day. But excited to be talking to friends and stuff. It changes my life a little bit. Excited.
Yeah, that's it. If we can just change it a little bit for better
just
or
enough.
worse. Just so it's different.
Just different.
Yeah. Well, we're also joined by a very special guest, Isobel Redelmeier. Hello, Isobel.
Hello. Glad to be here.
We're very pleased to have you. How's your week so far? I know it's only Tuesday, but how is your week so far?
Going pretty well. Week 3 of new job, so
Nice.
it's a different kind of rhythm from the job search one.
Yeah, that's cool.
Or the visa wait one also.
Oh, no, thank you. Well, we're going to talk today about context. And I had a quick look in the docs for the context package. It says that package context defines the context type, which carries deadlines, cancellation signals, and other request-scoped values across API boundaries and between processes. Emphasis mine. Who wants to have a go at explaining what that means?
I can talk a bit about how the latter part makes things exciting for things like open telemetry, where you really have like a lot of use case for distributed context, distributed as in across process or over the wire, or we can dig into that after.
Yeah, actually, that does sound amazing. I want to hear about that because it does mention API boundaries and between processes, but I've only really used context within a single program, right?
Do we want to start with the within process one or cross process. Might
We'll start with
make
the
sense
simpler.
to
Yeah. Yeah. I mean, imagine, so for if there's any beginners out there that haven't perhaps, well, maybe they've seen this and don't really know what to do. Maybe all they do is just pass context to do every time, good on them.
It works.
Yeah, it works. Yeah.
much better than nil.
Yes. The docs actually say you should never pass nil. We can talk about why that would be too. So it's really it's a way to kind of cancel things, indicate this process is going to stop for some reason, isn't it? Like in the HTTP world, every request has a context. And since it runs in its own Go routine, and of course it can spin up other Go routines to then go and do work, if the user cancels that request, it might be nice in some cases to abort the work and have a little bit of a saving. And you can also use it to pass values around as well, can't you? Request scoped values. What's that for?
That's a good question. So I actually like the context package for cancellation stuff. I think that's the main usage that I would recommend for inside of your own process, right? Like passing data inside of context, I would think very, very, very much before starting doing it, because otherwise what you end up is just having a bag of stuff, and it can be pretty bad idiom to follow. But for cancellation, the cancellation, the way I normally explain why context makes sense is that, like imagine that you have something very expensive to do, and after 1 second out of 1 hour of computation, the user decides that they don't care about this anymore, or they just crash, right? Like you don't want to do that whole hour of process for no reason. That's why cancellation makes sense. And the way you implement it is actually interesting, because like the idea is that you could technically keep these data somewhere else, and many other languages do that. So for instance, for Java, you have thread locals. Go doesn't expose thread locals, which means that you actually need to make that explicit. But making it explicit and passing this context around like all the data is not an easy thing to do. Like you would need to keep on adding more parameters to your functions as you go. So context kind of solves that, and it also provides the possibility of passing things that you don't even know you're passing. So as a function, if I receive a context, maybe in that context, there's some value that one of the functions I'm going to be calling will retrieve. I don't even need to know about that. So it's like those sides is like cancellation, and then kind of like generic way of passing data that you don't care about.
Can we say in a way that in the critical path of a user request that you are going through a lot of different things, right? It could be a lot of like microservices, or in the same microservice, you may be bouncing between different Go routines. Some work might be getting done in one Go routine, and some of the other one is just getting done. So in order to coordinate all that work, we sometimes need to pass some values, and as well as need to single some, life cycle related events such as cancellation. Because let's say that like you want to, if the user canceled some task, all the lower end, services might have received some incoming requests to do some work about it. But, we already know at the higher level service that it's just not required anymore. So, you may want to propagate that signal to cancel all the work. It also applies within the same process that you're sharing some work among multiple Go routines, for example, and then you want to just cancel all that work because we already received some additional signal that that work is not required anymore. So it gives us this good unified way of, passing around some data and passing around some lifecycle signals inside the same process, and as well as it gives us a foundation to do this when we are going to, other processes, other services.
Very much so.
Yeah, I was able to summarize your thoughts.
Yeah, I'm actually curious. There are the two things, right? It's cancellation, so making sure that unnecessary work is not done, and then the other thing is passing values, and they're very different, right? And for me, the weird thing is that they're the same thing. They're the context, and I feel like they could have been completely different things. right? Because the way we pass values, like it's useful because, for instance, like the traditional example is like, well, when you're logging, you might want to log like a request ID. And no matter what function is logging it, like that request ID should always be the same because that's what makes sense, right? Like that way you can see all the logs for this request. But that is completely unrelated to the fact that maybe that coroutine, like that request should be canceled. So I feel like we put them both together just because, like once you have cancellation and everything and you define an interface for it, you could also put values in there. So why not? But also it could have been completely different things. And I think that it's important to think about context in that way. And the fact that it does two things that are completely unrelated and that you can use one without even ever understanding or looking at the other.
I find deadline on context to be kind of an interesting bridge, since on the one hand, it has a lot of functionality that is similar to more general purpose cancellation. On the other hand, it is kind of this special value where you can check the active deadline on a context, last I checked.
Yeah, true. So it's kind of like metadata that you like. It's data around the cancellation. So it's technically you're also passing values, but that value you use it for cancellation. So yeah, That's kind of in between. That's true.
And for anyone listening who isn't familiar with how it works, under the hood, Go will respect the deadline. So if you have something that goes over the deadline, it'll get canceled automatically. You don't need to manage that yourself. Well, assuming whatever code you're using handles it. So for example, SQL will do it for you.
Yeah, you're right. So it's interesting that this is something that's quite unusual in Go because it is serving multiple kind of purposes, isn't it? And you probably could actually, just by having values, you could probably have a channel in there which you could close and stuff. But having it as part of the sort of official API does solve quite a nice broad range of problems for people. And I always think, like, if you're not sure what to do with the context, if you're working on some code base, you really just sort of pass it around. If there's anything you're going to call that takes a context, give it the one that you got if you don't care anything else, if you don't want to manage the life cycle or in any way. But sometimes it is useful to say you're going to make a third-party API call. You might decide, I'm only going to wait 1 second, and then if not, I'm going to fall back and use some cached version or something like that. And then you can create a context from another context. So does that create a kind of tree structure then?
Yeah, totally. That's kind of the idea, right? Like if for instance, like when I tell you to do something and then you go and ask 3 other people to do something else because you need those things so you can do the thing I ask you to do. Once I say, oh, I don't care about it anymore, you should also let others know that it is not necessary to continue. And like cancellation, like creating those contexts, it provides that. The interesting thing is that implementation wise, that's also how it works, right? Like what you're doing is that when you do with deadline or with timeout or whatever, what you're doing is literally creating a new context object that refers to its parent context. So you're literally creating a tree, yeah.
That goes for any value you add to the context also.
So when you access values then, and this kind of points out, I think, one of the dangers of context. When you access a value from that, you basically pass in a key, which is of type interface. So that means it can be anything. Anything can be a key. And you get back an interface because, of course, it is kind of generic in some way. And this is what generics in Go kind of looks like for now. And you get a second Boolean, don't you, of whether the value was there or not. Is that right? And so what's the danger there? What do we lose by having that way of accessing and storing information?
You need to handle the type checks and existence yourself. And you also need to make sure that you don't have key collisions. So there's an idiom basically around having dedicated structs for each of the keys that you care about. So that you don't, for example, use a key called a string called key, and then have collisions with everyone else, for example.
Yeah, that's actually a very good point. It's something that not that many people actually use, but that's something that's like when you want, so if you're creating a package and you're going to be storing data that you know that you're going to be retrieving later, instead of choosing a string or an integer, no matter how complicated the string could be, right? Like you could find a like super fancy string that no one else will repeat, or I guess you could also like copyright it if you want to. But the important thing is like instead you could just use even an empty struct, and an empty struct with a type that is not exported. Because when you're comparing two different interfaces, the first thing you do before you compare anything else is compare whether the type is exactly the same. If it's not the same, then it's different. It's different values. So then you can just like have like, normally what I do is like type key, empty struct, and key in lowercase. That way you make sure you don't have ever any conflicts.
Mm.
And there's an example of this in the Go doc, by the way. If you take a look at like with value, it's kind of like harder to explain this concept, on a podcast, but there's an example. And that's almost like, how you use canonical, how you create like canonical key types. So there's no collusion. Like you create your own key type and use that.
And would you recommend exporting those keys so that people can access the values, or is there a better way?
No, never. Because if you export it, people will mess with it. Like the whole idea is like context can contain so much stuff that if you allow people to start using it, then you're going to start getting really weird designs, right? Like you could do something that it could say, like this random package is going to start depending on another package having introduced a value and things like this. And now you have like these weird dependencies across packages that is not code dependencies. It's not in the code. There's no imports or anything. It just like, it happens to expect things. And that is just like, you would end up in like dependency hell, but in a slightly different way, all inside of the context. So I would say that instead of doing that, like for logging, for instance, like I recently created this little logging package. And what it does is like, it actually, so for an HTTP request, it will get the context from the request and do something like logger.with, I don't even know, from context or something like that. And it will put in the context the key that is private and no one else can find with the value of my logger. And then when you want to retrieve it somewhere else, you do from context and you pass that context. And that will give you a context with the right type. So that way you avoid collision, and also you avoid the having to do that conversion, like the type conversion from empty interface to whatever type you're actually using.
Totally. And then the from methods or functions generally, it's nice to either return the Boolean or return some sort of empty nil type that still behaves the same way. So at least users aren't going to have nil errors from your value.
Mm.
Yeah, so for the example of the logger, right? Like when you do from context, if the context that you passed didn't have any logger in it, it just returned default logger that logs into standard output.
Right.
Yeah.
And so if a question, so in this world, Francesc, that you made earlier, where I'm somehow a middle manager in an organization where you're the boss, and I've got people and, the contexts that have been created from mine, if one of those that asked for a value and they don't know what it is, they don't recognize the key because it's private to something else, what happens then? How does the context work?
Oh, so if you try to get a value from a context?
Yeah, if in child, it's not in the child context.
Oh, so yeah, you will go up the tree, right? Like this goes for basically every single feature of context, like deadlines and cancellation and values. What you're going to do is, if it has not been changed by your context, if you have not kind of redefined it, because you could hide the previous value for a key. But if you have not done that, what you're going to do is you're going to check on the one you have. And then if that doesn't contain the value, then you're going to basically call get value, like the value function on its parent, and so on until you get to the empty context, which is the one you get from background or the to-do context, and which do not have parents. And then at that point you stop and you say, nope, could not find it.
Mm-hmm.
Oh, just that happens seamlessly for you.
Yeah.
You don't need to think actively about the tree.
Yeah, so that's why like some people will think like it feels like you're using a map when you get a value, but you're not. You're actually using a linked list.
Mm. That is really cool. And when you think about cancellation as well in this sort of tree, you could imagine kicking off a few subtasks to go and do some work. And, you might cancel just one of those subtasks, or it might have its own deadline. If it then has created others, they will also get cancelled. So that cancellation, that's how it sort of propagates down, isn't it?
Exactly. And similar thing with deadlines, where if you have, let's say, a job that has a bunch of serial tasks, so you want the whole thing to take 1 minute, but you want each task to take no longer than 5 seconds, then you can say, okay, each of these gets its own deadline. That is the sooner of 5 seconds from now, or the end of that initial 1 minute deadline.
That's really cool. And you do that by using those functions on the context package, don't you? And you pass in the parent one every time. That's very cool. Yeah.
The cool thing about it is like, so I actually gave a talk long time ago. I do not know if you remember, you were there, Matt.
I do remember.
In Italy, GoLab. And I decided to do a keynote with live coding, which is a bad idea. Now I know. But so I decided to give a talk on re-implementing the context package, just because there's one thing that is really, really cool, which is how when you cancel a context, how all the children contexts get also canceled automatically. And it's like this very cute way of like managing Go routines and channels. And it's like the way it works is like very satisfying as a gopher. Like when you see it, you're like, oh yeah, this is definitely idiomatic Go. Also not something that I can explain in a podcast. So, go read the code, I guess.
Well, we'll put a link to that talk in the show notes because, yeah, you basically implemented the context package just as a talk live. It was very very impressive.
No, it was bad. It was a little bit of a failure, but I did then on Just for Funk, I made a video on it that I actually like had the time to edit down to remove all the things where I failed, so it looks much better. So if you add a link to that one instead.
Okay, fine. Yeah, we'll do the good one.
The original package's code also is quite readable, well documented.
Yeah.
Yeah, and it's in the standard library, isn't it? Was that from Go 1.15?
It's been there for
something.
1.6, 5 or 6 or something like that.
I think, 5 or 6, yeah.
Oh,
yeah.
I think 6. The only reason that I can tell it was 6 because we had App Engine runtime supporting 1.6 for years, even after like 1.6 just went away because of this context package related stuff related to gRPC, which is like another dependency hell type of situation. But I think it was 1.6.
Yeah. Before that, it was in X context for a while.
Yeah. And before that was internally at Google.
Yeah.
For many years, it was actually part of like networking package or something. I think it was like internal networking package. And they changed the implementation completely before open sourcing it, but they left the API exactly the same. And I think that is like a clear like proof of the power of interfaces, of the fact that we went from having one thing that does everything to having a bunch of different contexts that are like, they create this cool tree. Before it was not a tree, but from the point of view of the user, you don't care. So they were able to rewrite the whole thing, make it much smaller and efficient without ever changing any interface.
It's a good testament to the interface design itself as well, isn't it?
Yeah, definitely.
So if you're writing code that's going to take a long time to do something, let's say you're walking a file system, so you're using file path walk, how would you be sensitive to that context, either passing a deadline or being cancelled at some point?
The first thing is you should get the context. So like if you're getting it as, like from a function call and you have the first parameter, it should always be the first parameter for no reason really, other than that's how we do it. But yeah, you should receive it and do something with it, right? If you are not receiving it, doesn't mean that there's no context. It might be that you are missing it out, right? And that's something that lots of people miss, is the fact that when you have an HTTP handler, there's a context in there. You don't see it directly because it's actually hidden behind the HTTP request. So if you do request.Context, then you get the context. And that was actually done this way because if we had added the context at the beginning of the handler as an extra parameter, then we would have broken every single interface of the HTTP package, which would have been sad. So that's how you do it. So I would say like the first thing is like make sure you use it and that you get that context. And then the next is check that whether it's canceled or not. And the good thing is that basically the way you do it is just getting it's just a channel. So you do a select statement. Is like, as you were doing from a channel, is like, I might either receive a context cancellation or something else might happen, right? So you need to change a little bit your code. And if you've never done that, it's a little bit confusing. But the idea is that you should have the path that does the thing that you actually want to do and the path that handles the cancellation. And if you just do that, like if literally just that on every single HTTP, what is the word? Handler. As if you have in every HTTP handler, you just do that of either like, I'm going to call this function, but also if this happens, just cancel it. If the user just like sends a request and cancels the request because the TCP connection goes down, that context will be canceled. So even if the user that is hitting your REST API doesn't know anything about context, you're already getting a lot of benefit from it.
You can also stick that check into a wrapper handler, like basically middleware, so that you don't need to remember to add it to every endpoint. I know that this is audio only, but basically raise your hand if you've ever had something that is that you're adding manually to each endpoint and you've forgotten to add it to one. I certainly have.
Yeah, copy pasting is the best.
You mentioned something, really significant, I think, affecting people, which is the fact that, context packages, added to the standard library at a later time, 1.6. And now, in terms of APIs.
Sorry to interrupt, but actually I just looked at it and we were wrong. Is Go 1.7.
Okay, good.
Off by one.
Which was the drama because Go 1.6 did not have context, and that's the one we were supporting on App Engine, and everybody was mad at that. I remember that, yeah.
We were right about there was some drama related to 1.6, but it was because 1.6 didn't have the context, not because it had the context. Yes.
Off by one
cool,
error
thanks.
again.
Yes.
Close enough.
We're programmers.
Yeah.
Yeah, it created this sort of different APIs all around, right? The SQL package, for example, became very complicated after context because they had to introduce the same set of APIs with the context. So, it's just kind of hard to figure out people why all these, APIs are replicated and which one is the best one to use and so on. It also seems to be, I think, kind of giving a lot of trouble for some people just because they don't have this context. Context as in they don't have the history, how context came around. Context is the most overloaded term probably in computer science also. So I'm glad that we are having a conversation about this topic. But yeah, what I wanted to say is it is a challenge for people because, they don't know the history and it was more of a later thought. So I was saying if you're starting a new language, think about how you're going to be handling context propagation at the very earlier day because it has a real impact on the library ecosystem.
Very much so. And I think someone else mentioned earlier that, for example, Java has thread local variables. The problem that you run into with any language that has thread local variables, let alone only global variables, is that at some point, likely someone is going to want something that is finer grained than threads. So Go routines are one example of this that's probably familiar to most of the audience here. But then other languages, like let's say Python, for example, have things like futures, which are, again, different from threads. And so Python handled this by adding context local variables after the fact. But then if you're writing a library, you still have to handle the case of something maybe having something not yet supporting context local variables.
Yeah. And I actually have a follow-up question on that. So we have explicit context propagation with the context objects. In many languages, actually context propagation is implicit. And how does that, in your experience, how does it affect people's awareness around, there is TLS or context propagation. There is maybe signals that you can kind of use to cancel or you can propagate some values. I think in terms of awareness or in terms of usability, like explicitness is also a positive contribution. Do you agree?
I would say that it's one of those things where it's both good and bad. It's, on the one hand, nice that the implicit is kind of easier to use because you can access it anywhere. You don't need to worry about explicitly propagating and, oh, what if I'm using a library that doesn't offer propagation yet? What if I have a legacy code base that doesn't have context propagation yet? Do I need to play a bunch of vimgolf or regex stuff in order to add it everywhere? So on the one hand, it's nice that to have it implicit so you can just really easily add it from any starting point. On the other hand, making it easier means that it's also easier to abuse. So you can overuse it more easily. I've seen this a lot with languages that have like request local, or I guess libraries and frameworks that have request local variables, where people end up using this one like request object in Rails, for example, to propagate everything, their entire state. And then you end up with these like tiny little methods somewhere very deep in your code base that really shouldn't know about this, what is like almost global state, but is coupled to this massive object that it just kind of conveniently has. So it's nice until suddenly it's not. And when it isn't, it gets bad.
Yeah, I've seen examples of like people can't break the API, so they actually have to like put things in they end up like putting things in context, and like it becomes this like, I think it's called the God object. Like you just basically, your API is represented on the context propagation, which is an anti-pattern, but it happens way too often.
Yeah.
And there's no compiler safety, is there, in this world? The compiler's not going to help you out at all with these, because you only find out at runtime if the values are there or not.
That is true in most languages. I think some will give you some more safety.
Yeah, but even like you could somehow fake that in Go, right? Like you could have a request object and then like add more and more fields as you go. And then each handler kind of creates a request object and then calls something. And all of those are methods. So you always keep that context. You can always access it. But if you do that, you're going to write code that is so hard to test. Because you're going to have this object thing that it goes on over and over. And that's why I was like, if you're writing code that uses context, most of the time you actually do not have access to anything in that context. Unless you know what you want, right? So you cannot be broken by things that you don't have access to. So it makes it a little bit easier. By making it more restrictive, it actually makes it so it's harder to misuse. And I feel like that's something that Go tries to do all of the time, like to make things easy to use, but even more important, hard to misuse. And this is an example of that.
God object is a pretty searchable term these days, I believe. If you want more articles on people talking about the woes they can cause.
What I wonder about, and actually I don't know about this, but Isobel, you might know, for other languages, when context propagation is implicit, if you have something where you have a for loop and each iteration needs to do it in a different context, can you even do that? Or do you need to somehow go into like actual threads and stuff like that?
So that's a good question, and it varies by language. So if you have something that has, let's say, kind of worst case scenario, only has global variables, kind of base case basically, then you would need to add locks and stuff in order to ensure that if you're trying to parallelize that loop, let's say, that they don't clobber one another's state. If you have something like context local variables in Python, then you have it per future, I believe. I don't write much Python. I'm starting to write a lot more Python right now, and it is making me miss Go. So far, where was I going with that? So, like, if your parallelization is using something that maps nicely to your context local variable type, like futures that are aware of context local variables, then you get it for free. However, if you have something that, if you're using, let's say, futures, and you only have thread local variables, then again, there's this mismap. And so you need to add a lock or something in order to ensure, again, that you're not clobbering state across one another. It's kind of that same classic global variable problem. And sometimes it's better mitigated, sometimes it's really not.
What's up, Gophers? Are you looking for a way to instantly debug and troubleshoot your applications and services running in production on Kubernetes? That's a mouthful. Well, Pixie gives you a magical API to get instant debug data. And the best part is this doesn't involve changing code. There are no manual UIs, and all this lives inside Kubernetes. Pixie is an API which lives inside your platform, harvests all of your data that you need, and exposes a bunch of interfaces that you can ping to get data you need. Pixie is essentially like a decentralized Splunk. It's a programmable edge intelligence platform which captures metrics, traces, logs, and events without any code changes. And the team behind Pixie is working hard to bring it to market for broad use by the end of 2020, but I'm here to tell you how you can get your hands on the beta today. Links are in the show notes, so check them out so you can click through to the beta and their Slack community. Once again, links from the show notes, check them out, and look forward to Pixie Day coming soon.
So we've talked about context from in an HTTP context. So we can access the context method on the HTTP request, and we can also use with context on that to get a new request if we want to set the context in a request. Are there other places? One thing I'm thinking is I actually use context in my normal tools in Go, in like command line tools, and I have the signal, the Control-C signal interrupt to actually cancel the context. And that turns out to be quite a nice pattern. Does that break the rules a little bit? Some people think that you should only be using it in a kind of request response world, but then maybe a CLIs are kind of request response.
I would consider them request response. Slight side note, Dave Cheney has a couple parallel articles. One is called Context is for Cancellation. The other is called Context Isn't for Cancellation. And it's been a while since I've looked at the articles, but as I recall, they kind of dip into this a bit.
Yeah, that's the series from Dr. Cheney and Mr. Dave. They're giving us two sides of the same argument. Yeah. Well, I saw a proposal, and I think it's making good progress for officially supporting that signal cancellation that I was talking about. I think they were talking about adding something either to the signal package, I think, so that you could trap, and get a context that will cancel when it sees those signals. That can be very useful. One thing I just want to say for anyone that hasn't used this to sort of implement the cancellation, there's a really cool thing. The done method returns a channel, and that channel gets closed when the context should end. So if you're doing like a select block or something, one of the cases can just be a read essentially on that done channel, and that's the little bit of code that runs when there's a cancellation. And then in that, usually you can either return the error or exit or something. Maybe you need to do some tidy up. Hopefully you've deferred that or something so it happens kind of automatically. Are there any other little programming tips and tricks like that we can use that you know of?
There's one that it's pretty cool, which is if you're going to have, like, there's a very straightforward way of cutting down the latency, like the tail latency in your requests. So if you have a request, let's say that you have a request that you send into a server, and it takes 5 milliseconds 99% of the time, but then there's 1% of the time that it takes 1 minute, which is not good. So what you could do is make that call multiple times, and you're going to do it with cancellation. So you're going to do context with cancel of your original context. And then what you're going to do is you're going to use the same context for all of those calls and have defer cancel at the top of your function. And then as soon as any of those values returns and you return from that function, the rest will be canceled. And that's going to take down your 99th percentile from like 1 minute down to 5 milliseconds. So that's like small things that you can get a lot of performance, especially when you're using a server that is not something you manage. So you cannot go and complain to them about like, hey, your 99th percentile latency is awful. You can still fix it by doing this little hack.
And for those unfamiliar with tail latency and its implications, what can happen is that you have what's called a long tail, where some small percentage of your requests take all of the time, and often alongside all of the time, a lot of the resources. So if you, rather than letting them take all of the resources, instead cancel them, it can actually improve your throughput by freeing up those resources for the faster requests.
That's brilliant. Why is one of them taking a minute? What's it doing?
It's telling type.sleep 60 seconds.
Databases.
Yeah, databases. One service is down and something is doing infinite retries. Network issues. Always network issues somewhere. DNS.
There's a really good talk by, what's his name? The guy that does everything at Google. There's even like degrees of separation from him. Yana, you need to know who he is.
Jeff Dean, who is that?
Yes, him, Jeff Dean. So
that's impressive.
I didn't assume that you can forget his name, so sorry.
It's the guy that does everything at Google, basically. Like everything is emailed by him somehow. He has a really good talk on like how to manage tail latency and long tail latency. And it's really good, and that's actually where it's like it's not for Go, but all of those things that he proposes are actually things that you would implement in Go with the context package.
Ah, cool.
Yeah.
Tail latency is not unique to Go.
Oh yeah, absolutely not.
Yeah.
Alas, if it were isolated in one spot, that would be nice.
That's one of the reasons that like context propagation deadlines and cancellations is a big part of our RPC, systems, like, our RPC stack. And it's, the context package, the Go package kind of like grew up from there, internally. When we were talking about the internal context package, it was actually in the context of like the, RPC framework that we were using. It was back then Stubby, now it's gRPC. They are both using, similar concepts. And it's very important for gRPC to have a context propagation building block like that.
On the note of gRPC and more code examples, a lot of the gRPC Go code around context is also pretty readable. Like for example, there's a peer package which is almost only for context handling. So it basically has, I think, two functions: one for adding peer to a context, one for retrieving peer from a context. So you can see how it works in the wild.
Oh, that's a great tip. Yeah. There's another thing that was quite interesting. We had a problem where we were using IO copy to copy from some source data to some destination place. And it's takes the IO reader, IO writer pair. And we wanted to cancel that. And because you can't pass a context into copy, the way we solved it was we made our own reader that essentially wrapped the other reader. And this reader was context aware, so that it would check to see each call to read, which happens multiple times as code as IO copy is reading through that source data. Each time it would check to see if the context has been cancelled or if it's going to return an error. And then if it did, it would return that error from the read method, which then would propagate through and would get returned from IO copy. So that was an interesting solution to how we could actually add context support to places that don't yet have it. Those kinds of things are crazy, aren't they?
That's interesting because like I really like the solution. It's like when you mentioned the problem, I was like, oh yeah, that's how I would have done it too. But also, does that mean you were storing a context in a struct? How dare you? That goes against what everybody says you should do.
No, we didn't, because we used the closure, I think.
Oh, maybe. Sure. Okay. Yeah.
I was about to give that as an example. Lots of people are asking, for example, this particular thing, like how can you, get rid of a Go routine once you're done or whatever? What is the most canonical API? One way to do this is actually using cancel. Like if you have this infinite select, for example, you start a Go routine, there's an infinite select, whatever. You can just basically rely on that. I'm not sure if I was following your example, Matt, but was it something like that? Like you had some task and just basically using cancellation. So the context is a way to signal that cancellation and, lifecycle events.
Yeah, it was. It just, because you can call the error method, can't you? The ERR. You can just call that anytime.
Yeah. That and done.
It's nil while it hasn't been cancelled. So I don't think we used the done channel in this case. I think it was just checking that error. And if that returned nil, then it went and allowed the parent to do the read. And if not, it would return and short circuit early. Yeah.
That's pretty cool.
Yeah, it worked.
Yeah.
We wrote about it on the blog. I'll put it in the show notes, everyone.
Yeah, the IO copy example actually reminds me of what gRPC does for streaming. So if you're doing bidirectional streaming, you don't know who's supposed to finish. So you actually handle that by canceling the context. So it's kind of similar to IO copy, yeah.
Oh, yeah. That is cool.
Loops are a good place to have that repeated check. So if you have something expensive, like maybe you're copying a really large file, you can instead copy pieces at a time and then do the check after copying those pieces.
Right. Yeah, actually, when you walk the file system from my example from earlier, each time you check, I often check the incoming error to that walk func that you get. And then if there's an error there, that'll be the end of it for me. And then after that, I'll check the context error there. And if there's an error there, I just return that kind of in a similar way. And yeah, so it can be it's quite simple and very easy to read. And it's just normal Go code, which I quite like. I mean, I get how having it implicit might make for a kind of less cluttered language, but a little bit like the reason we like errors in Go is you are explicit, you can see what's happening and you sort of are in control of it, which is quite nice.
And actually that's a very good point about errors, because if the cancellation was implicit, like if you didn't need to do anything, your code would just be canceled, then you would need an exception, which we don't have. There should have to be like some extra weird thing in there, or like a panic. Yeah, which would be pretty bad. I think it'd be pretty weird to do.
The only language I can think of that doesn't have exceptions and has, in some spots at least, something like an implicit context local is Rust, where some of your like future engines basically have context local variables. But they don't know about cancellations. It would be up to your HTTP library, for example, to add that on top.
Yeah, and the problem is sometimes you actually do want to do some work in the event of a cancellation. You know, if you've got some temporary files, or there may even be additional things. Maybe you have to update the state of some task somewhere in some database. You know, there may be actual active code that has to run during that cancellation, and having it explicit lets you just spell that out right there, which is, I think, pays dividends always for maintainability.
Yeah. Also, having it explicitly allows you to do something which is kind of an optimization. But like if you know that a task takes 5 seconds at the beginning before you start doing it, you could actually look at the deadline and looks like, oh, I only have half a second. There's no way I'm going to finish. Just return error.
That's a great idea, actually.
You don't need to even do it. Yeah.
Yeah. Huh. That's another one I was thinking.
There's a cool thing about, is it about this topic, or because I have another topic that I think is kind of interesting.
Yeah, no, go for it. I've forgotten, so snooze you lose.
Okay.
Yeah.
So yeah, it's like, why is there context.todo?
Great question.
Yeah.
I don't know.
So context.todo and context.background do exactly the same thing. They return an empty context. In an empty context, that doesn't have values, doesn't have timeouts, it never gets canceled. So it's like literally an empty struct. That's what it is. So the interesting thing is that when you return background, what you're saying is that, this is something that I'm starting from scratch. So you're basically saying there's no previous context. This is something that I'm creating, right? So for instance, in the example of the CLI, you're running your CLI, and at the beginning, there's no previous context or anything. Like maybe at one point, we will have actually a context coming from Signal. That would be an interesting thing, but otherwise, we don't have anything. So you would call background. Context.todo was added just so as different functions, like you need to start, like you're creating a tree of functions that are calling and passing context around. So how do you do it if you want to add it to all of them, but little by little? Like if you start from the top, it's going to be, you cannot pass functions until they're accepted. But if you do it the other way around, like you build a function that starts by saying, oh, I accept a context now, and you can pass a context to me. Then the caller could say, oh, okay, so I should have a context, but I do not have it yet. So instead of calling context.background, which implicitly says, I do not have a context and I will never will, so to do is just, hey, I do not have it yet, but let's fix it later. So it's literally just so when you grab to do, you can find where you need to still do more work. And I think that's kind of cool. Like the fact that they thought about these. Otherwise, I mean, you could have done the same, calling context.background and then having on top like a comment doing to do pass a real context.
Yeah.
But they did it this way, so it's more explicit, and you actually could do code analysis and look like, hey, this is not done yet.
Yeah.
And that's a very real use case. I mean, one example that I've encountered multiple times is trying to add distributed tracing to existing code bases that don't use context yet. So I kind of hinted at this before, but most open source distributed tracing libraries, at the very least, use context to propagate what are called trace and span IDs. So basically your metadata, keeping track of the trace. And so if you're adding it to an existing code base, you don't have those contexts yet, then you don't want to be starting spans from scratch. You want to be able to connect those spans to one another at some point, but not necessarily from day zero. If you have, multi-100,000 line code base and you have a lot of context to re-add.
Yeah, that's a really good point. I mean, you can tell that this came out of real engineering, the fact that it has that to do and the fact that it kind of, as you said earlier, Francesc, it is a kind of very elegant design. It's a very elegant solution. And I think it's worth looking at. There isn't much code, as you say. It's worth taking a look. And some interesting things in there too, like there's a string method often on these contexts. So when you print them out, they tell you kind of meaningful information. That was a surprise when I found that in the code.
I actually didn't know.
Yeah.
I didn't either.
Yeah. Okay. Well, it could be wrong. If it's wrong, it'll get edited out so I don't look like a fool.
Or did you make that up?
I have certainly printed contexts before.
Yeah.
You can do it. It hasn't been super pretty in my experience, but when in doubt, I have printed many contexts.
Yeah.
If it's just string, like if it's just primitive stuff, yes, the print will tell you something. But like in most cases, in my cases, for example, it's either another struct and it doesn't provide you any, nice string, then yes, it's getting harder to use it as a diagnostic tool. Yeah,
you probably can't, no, but I've seen it for at least telling you the type of that context and things, because often you pass around the context.Context interface and sometimes that, well, hopefully not. But
yeah, no, I actually tried it and it's kind of cool. The way it prints it, so I did it, I just wrote a little prompt, it's like context.background, and then I add a value. It was like key is 1 and value is 2, and then I print that. And what it prints is like context.background with value, and then the value inside. So it kind of creates like this linked list of like what are the things that you obtain and prints it. Yeah. The key is type int, so it doesn't tell me what key it is. And the value is not a stringer. That's what it says. So yeah.
Okay. That's not useful.
Well, not incredibly useful.
Could be useful.
I'm almost sure that they don't print the value or the key just so people do not parse the result of printing the context and then use that to values.
Yeah,
because that could be dangerous, couldn't it?
Yeah, nice concern.
Yeah.
That would open a gap, yeah.
I think I've been able to successfully use it to either see if a key has been added, like basically, I still have an empty context.background when I expected to have some key on here, or else to see if a key has maybe been clobbered, but I don't remember how I was able to see the details there.
Oh.
Yeah, I guess it tells you the type of the key. So technically, if you're using only that private key, as we were saying before, and there's only one value per type, then in that case, you actually know what value it is. Yeah.
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 What's up, Gophers? Do you have an app in production that's slower than you like? Of course you do. I know. But seriously, is the performance of your apps all over the place? Sometimes fast, sometimes slow? Do you even know why? Well, with Datadog, you will. You can troubleshoot your app's performance with end-to-end tracing, and in one click, correlate those Go traces with related logs and metrics. You can also use Datadog's detailed flame graphs to identify bottlenecks and latency in your apps. Start tracking the performance of your apps today with a free trial at datadog.com/GoTime. And here's a bonus. If you sign up for a trial and install the agent, Datadog will send you a free t-shirt. That's a nice bonus. Once again, datadog.com/GoTime.
Well, before we call cancel on the context of this episode, it's time for unpopular opinions. So let's hear them. Does anybody have an unpopular opinion this week?
JSON isn't always as bad as people make it out to be.
Tell me more. Who is he? Who is this Jason you talk about?
Yeah, that Jason who gets so much flack.
Why are you defending him all the time?
Yeah, well, I've seen a lot of people switch, in my opinion, prematurely to protobufs in particular, sometimes to thrift, where you just change from one problem to another. And especially, I think, for anything that is used externally to your company, so for example, open source code, protobufs can get very complicated, especially if you're exposing something that is going to be used across multiple languages. So nice to use in Go. Not necessarily as nice to use in Ruby, for example, or in PHP.
Yeah, or indeed the web browser. Actually,
Yes,
we
that's
did
a big one.
we did an episode on this very recently. We called it Encoding JSON, and we actually spelled the episode title using JSON to see if any podcasting technology is vulnerable to JSON injection attacks. So far, everything's just been fine, which is a shame. But yeah, I completely agree, actually. I think we tend to get, as programmers, a bit obsessed with, it's a very attractive proposition, the binary protocol. It's so tiny, isn't it? Binary is so tiny, where text is this, wasteful big thing. So yeah, I get why people are drawn to that, just from a sort of technical kind of pure engineering drivers.
Yeah.
But yeah.
There are also people who kind of associate gRPC with HTTP2 and don't seem to realize that you can use HTTP2 without gRPC, but not the other way around. So they think, in order to use HTTP2, I must use gRPC. In order to use gRPC, I must use protobufs. And it changes a ton of things, where you could often get some part of the win more cheaply just by switching to HTTP2.
Great.
Or using message pack, using streaming, various things like that. Without going wholesale.
Brilliant one.
Can you use streaming in JSON without, or that's when you would say you should move to gRPC?
You can. It's not always as pleasant, although I've also seen enough issues with gRPC streaming. And to Matt's point, I think that you still can't use gRPC streaming in browsers, for example. So there is now gRPC for the browser, but I believe it's unary only. One day maybe I'll write a blog post or something on how to do basic streaming and when it stops working.
Yes, please. Yeah, I've done a JSON streaming thing, which was just using the line feed. But we also found out in that episode that it's buggy if you just use the JSON encoder on the body, on the request body, and just use encode or decode, wouldn't it be, each time to read those lines. Apparently, there's risks involved, and if you want to know what they are, you have to go and listen to our JSON episode. Cross-marketing of episodes. That's what's happening. That's how good this podcast is getting. Any other unpopular opinions? I like that one, so I don't know if that's that unpopular, but maybe it is.
I don't know if it's popular or unpopular, but I think that generics in Go are a good idea. I would say that's unpopular with many people that I know. But I do think that I gave this talk a long time ago around functional programming in Go and basically why not to do it. And one of the biggest reasons, there were two reasons. The first one is because there's no tail recursion optimization, which means that your program is actually 10 times slower just because of it. So that's, that's a small thing that maybe we should fix. But the biggest thing was the fact that if you want to do any kind of interesting composition of types without generics, you're out of luck. You cannot really do it. You need to do empty interfaces everywhere, right? So generics, I am very excited about seeing them. It's like I've been trying them and how they look. And now that, contracts are kind of like gone, or at least like they make much more sense. They're not as complicated as they used to be. I'm pretty excited about getting to use it. So I don't know when it's going to be released for real, but looking forward to that.
Yeah, I think the design work is phenomenal. And I like the fact we've been able to see it evolving as well. I think that in itself is quite an interesting study of language design. And again, there's another episode of Go Time, your favorite podcast, where we actually speak to the designers, Ian Lance-Taylor and Robert Gressner, on the show. Yeah. So put that in your ears. Jana, do you have an unpopular opinion?
I have a controversial one.
Oh, let's do it. Let me just re-record the theme tune then. God, no, what's your controversial opinion?
I do think that, I really like Go as a language. Like the simplicity and, verbosity-wise, it's just one of the best options that you have. But all the proto-generated artifacts is just making everything just kind of messed up. Each time I have to touch, some proto-generated protos, it just doesn't look like Go anymore. It's so cryptic. There's all these types on top of the standard library I have to learn about. Proto has its own struct, all of the mess, and even the timestamp, for example, type is a completely different representation. So you basically have to adopt into that verbose alternative universe, and it's just my main pain point. And I've been trying to collect all these gotchas and tips and everything about protos for a long time, and I can tell you there's at least 20 pages of me putting some tips here and there, and I still need to go back to that document and reference to be able to kind of take a look hey, this is what I'm supposed to do if I see a type like this, put proto-generated type like this. And that's just a big struggle to me. They've been trying to improve the generated artifacts, but it's just too late, I think, to make anything significant. And to be honest, working for a company that is so proto oriented, that's the prototypes are the types that I'm engaging with on a daily basis. And it's just takes away all the fun I get from Go. Because in the end of the day, I'm a proto, I'm engaging with the protos more than everything else.
Yeah. So that's interesting, because I found the same. And actually, I've deliberately avoided gRPC and protocol buffers for that reason. We actually I've told you about this before for sure. Let me just quickly tell you about this other alternative project that we've got, which is just a code gen thing, but it uses Go interfaces to describe the RPC. So you have an interface for each service, and then the methods in there, and then you use Go types. And then it uses the packages package and the AST stuff to understand those Go types, and then using templates to then generate server stubs, client stubs, TypeScript client, things like this, And it's JSON over HTTP because, as was mentioned earlier by Isobel, it's kind of, it's good enough for most cases, and actually preferable in some cases, because, we can open up the web client and have a look at the requests and the response going on in there, and look at the JSON, and it's even pretty printed by default and things. So it's there are trade-offs that sometimes we focus too much on one thing over others, and I think maintainability and familiarity and just having a sort of JSON HTTP thing, given that so many people already understand that so well, does kind of have that appeal. We'll put a link to that project called Oto in the show notes.
Ooh. I did a talk last year on gRPC that was basically gRPC war stories.
Nice.
I don't think it was recorded though.
Oh,
or
it
at least
wasn't.
I haven't found the recording.
Oh, that's a shame. You'll have to. Yeah.
gRPC conf.
Yeah, I'd like to see that.
There was a camera, so Google may have a recording somewhere, but I don't have access to it.
That's just intriguing. Okay.
I talked to the gRPC team about this, and like there was like one of the leads were actually interested in reconsidering, designing the generator, the product generator. But then that person left Google. And I have to like do some like grassroots movement again to make this a deal. But it's just so bizarre. Maybe it's because Go is such a significantly simple, like small language that, anything that just doesn't fit into that category just stands out too much. And you feel frustrated maybe because, like you're coming to this language because you want something very small and simple. And then, the reality, it just doesn't match. On the other hand, I mean, there's no other way to do like, multi-language, like if you want to use, proto-style transport layer, plus you need like multiple languages, there are a few other options, but none of them are like, they all suffer from the same problem because this is an inherently hard problem. You're talking about having, compatibility between different languages. Yeah, so of course you introduce some of these like additional types on top of the, the standard types. But, in the end, I think as a user, it's just making me sometimes unhappy, unfortunately.
Yeah, and there's another thing that I wish it didn't do. And when it generates the interfaces, it will somehow they made it so you don't get a compile error if you don't implement that interface. Like I think they embed a type that has all the methods automatically, so it's never a compile error. And one of the nice things I would have thought is when the definition's changed and you then regenerate your code, you then will get compiler help to make sure that you've implemented that interface. It probably comes down to, again, another pragmatic reason like context to do. But in Oto, for example, it's a compile error if you haven't implemented the interface. And that really helps us make sure that it's always correct.
Yeah, I think that the reasoning behind that might be something around like, I can add new methods and like on the definition, and those servers that are not satisfying that method yet, rather than not compiling, they will compile and they'll tell you, this is not implemented. So from that reasoning, it kind of makes sense. Yeah. But also, I got bitten by it recently, and I did not enjoy it. I was like, why are you compiling? Do not compile. Like, you're missing a method. Do not satisfy the interface. Yeah.
Does it return an error or something, or is it just a no-op? That because you need a response.
There's an implementation that just returns not implemented. So, at least it makes sense, right? Like, once you get the error, it's like, but if you got the error because, like you have a proxy somewhere that you forgot to update, and now you, instead of getting the whole thing going all the way to your server, now the proxy is just saying no, not implemented, and you do not know because it was not compiled. Like it compiles, so in Go, if it compiles, it works. So you break that, that's bad. That's
and if you don't have I saw code like this recently where it had the not implemented all over the place, and then didn't have a panic handler. So if you had your routing misconfigured or something, suddenly you were basically accidentally self-DDoSing.
Interesting.
Yeah. Well, I'm afraid that is all the time we have for today. What a great conversation. Thank you so much. I think I've learned a lot about context there. Don't forget to check the show notes because there's lots of bits and pieces in there that we've talked about today. Thank you very much to Francesc Campoy. Francesc, thank you. Thanks for coming.
Thank you for having me.
Yeah, mate. Anytime. Come back again, please. Another time. Will you? Do you want to commit to that now while we're recording?
Eventually. Yeah, sure.
Eventually.
Send me a DM. I might answer eventually.
We won't. And Isobel, thank you so much for coming. You'll have to come back as well. And of course, Jana, always a pleasure.
Thanks. Yeah, thanks a lot.
Okay, this is the longest long tail goodbye because it's the longest one we've ever done. But thanks for listening, and we'll see you next time.
That's it for this episode of Go Time. Head to the show notes and click discuss on Changelog News if you want to share some thoughts back to the show. Also, Changelog Plus is now a thing. It's the best way to directly support Go Time and everything else we do for you here at Changelog. Support our work, make the ads disappear, and get closer to the metal at changelog.com/++. The early adopter rate ends at the end of August. This episode was hosted by Matt Ryer and Yanabi Dogan, with special guests Francesc Campoy and Isobel Redelmeier. It was produced by Adam Stakoviak, that's me, and our music is produced by the one and only Breakmaster Cylinder. And we're also brought to you by some awesome partners who get it, thanks to Fastly, Linode, and Rollbar. That's all for now. Next week's show is all about building desktop apps with Go and web tech. So stay tuned for that.
Changelog plus plus.
Changelog plus plus.
Changelog plus plus.
Changelog plus plus. Changelog plus plus.
Changelog plus plus.